Good morning, everyone. My name is Baijian Yang, but I had a hard time when I just started out here in the U.S. without a sort of a nickname. So people always made a bunch of mistakes and pronounce my name, write down my name, and I thought, you know what, to make everybody's life easier, I just came up with a, sort of like a nickname. So I go by Justin. My students always just call me Justin. And I'm going to introduce one of the very interesting kind of educational piece of a cybersecurity project I'm currently involved with. And before we talk about that particular project called IEEE Try-CybSI, I want to briefly mention some of the challenges we're facing. I think number one challenge we're facing is the shortage of qualified IT security professionals. So the key word here is qualified. So I think one of the speakers talked about in the morning, there's a government agency trying to hire people, but then couldn't simply fill out the positions simply because the folks we have don't have the right skills, right? So this is one of the challenges we're facing. And then if you're looking at the cybersecurity by itself, it's a multidisciplinary, it's very complex. And often it's more than just doing the secure coding. And I also have a perspective of users are the weakest link in this cybersecurity system. So users are the ones that often didn't really pay a whole lot of attention. They're the ones who probably get the viruses installed on their programs. So just by doing the cybersecurity, the secure coding itself probably cannot fix the problem. So that's just my perception. So we need more people to aware what's going on. We want people to know what are the real things. What's really about something about, for example, SSL stripping, what exactly it can do to your computer, what is something like a hard bleed attack, why it costs billions of dollars for the industry to fix that particular incident. So those are things that's kind of really big out there for people to understand. Another thing is the whole thing is so dynamic. You probably, when I'm teaching the cybersecurity classes, one of the things that I have a lot of trouble to do is just reuse some of the core materials I developed last semester. So I designed the lab, I beautifully demonstrated this can be done in my system, and next semester, guess what? You have to redo everything because whatever the vulnerability you're trying to talk to your student, you simply cannot reuse that system again because your system is different now, so it's really hard to produce. So that's basically the challenges we're facing right now. And thanks to the keynote, Dr. Greg Shannon, and he had this great vision, and he wanted to come up with something that can accelerate innovation in cybersecurity and privacy, where this curated online access to high fidelity technical experiences. So Greg, when he was the president, or is it chairperson of the, is it chairperson or president? Chair? Yeah. When he was the chair of the IEEE Cybersecurity Initiative, so he realized this is something much needed. So he came up with this solution, this vision, and talked to the people in the community and tried to come up with something that can solve some part of the challenges. So one of the biggest problem we have right now is when we're using the cybersecurity, we have to rely a lot of the technology. Extremely hard to produce the results, and it's really difficult to run some of the demo. And here's the thing, you have all the different tools you can download, you can play with, and guess in reality what's happening? You download the tool, number one thing you got to realize is, oops, you got a compilation error. You run through the program, you download the program because it's more than likely it's open source. It has running different kind of library, making different kind of assumption about your system. So number one battle you have to fight is, well, I have to figure out a way how to make the system really compile. I have to go change the make file. I have to update my libraries and all that, making sure I can compile this file. And then you probably pass this age, and then the next thing you're going to realize is, okay, you still have something wrong with your system. So you still cannot pass the installation. Or in some cases, your installation is really, you can smoothly install the program, but you simply cannot start the process. That happened to many of the open source software I played with. It's very specific about the version of what kind of Linux system you're using, what kind of Unix system you're using. So And as you know, people are very patient, right? We will simply, close a web browser if that web page is not loading in 8 seconds. Okay, so 8 seconds we can just simply turn off the browser, and fixing those compilation error probably take good hours, or in some cases a few days or even weeks. Okay, so we have that kind of problem. So is there any easier way to solve this problem? So one of the approach we can think about it is, well, are there any way we can build this kind of a web-based approach where all the tools can be accessible from the web browser? And in the back end, what we're trying to come up with is using some sort of virtualization technology. Specifically, we're using Docker simply because it's a lightweight. So we can hook up the web browser with a Docker image. And in terms of hardware, because we're living in the age of cloud computing age, so we can simply using the cloud. And specifically in this IEEE project, we're using the Amazon EC2 to allow dynamic resource allocations and all that. So with that kind of architecture, we just briefly touch on the design of this project. So the user is on the bottom here. And the very first thing is they're going to log on to the IEEE Try-CybSI website. By the way, the URL is try.cybersecurity.IEEE.org. So you just log on to that website. And based on the website will give you, at the moment, it will give you 11 different use cases. You're going to pick one of them. And based on the scenario you're going to pick, it will direct you to two different scenarios. One is if you're using some of the coding-based containers, it will go with the Amazon EC2 container services because it's really easy to make, and it will dynamically allocate resources very easily. However, if you pick some of the network attack-based scenario, it will go to some of the container we created, because we have to build additional bridges to making sure that one container is not interfere with other containers. So going from there, it will connect to the backend Amazon containers, and going from there, it will load the fetch Docker image, and then return the container URL back to the web interface, and then the user can click on the application URL and begin to play with the tool from the web browser. I believe our design is capable of working with any of the mobile devices as long as you have a physical keyboard. It is not working extremely well with the touchscreen at the moment. It's something we're working on, but I'm pretty sure it's working perfectly on most of the computers. So eventually, those are the 12 containers in the first batch. The only thing we're missing here is the RSA. This RSA is one of the cryptography projects that's already made. It's already there, but it's still testing. So far we posted 11 on the website. The layout is slightly different, simply because we haven't put them into right categories yet. But eventually we're looking at here, we have 3 different use cases on the networking attack, kind of explaining what is ARP spoofing, well, how do you do SSL stripping, and why SSL stripping are able to get, achieve your username and password even though you're running something like HTTPS. So we have those, and those are the network-based the containers. It's highly vulnerable, so we put a lot of the security features in the back end to making sure that there's really self-contained, isolated. There will be no one be able to launch ARP spoofing on the gateway of the back end server. So we did a little bit of security control over there, and then we also have a second category go with secure coding or security basics. So we're looking at some of the high-profile incidents or some of the really common mistakes when people trying to write their programs. So we have a Heartbleed exploit, that kind of container kind of explain exactly what is happening 2 years ago about Heartbleed break. And we show you the code that has trouble. We'll also tell you how people fix the problem. And then we give that information to you. And I can tell you this, we actually spend quite a bit of time just try to find the right version. Simply because your current Unix systems or Linux system, they're smart enough, even if you load older version of the glibc, it still be able to fix the problem. So just simply reproduce the problem took our team quite a time just finding the combination of everything to present it there. So at the moment, I think there's a little bit more. I want to work on this particular instance to make it more, interactive. But we are able to reproduce what is going on. And of course, old-fashioned SQL injection is really easy to understand using a container-like a case. And the resource authorization is really linked to one of the IEEE white paper on the top 10 design flaws. And we want to kind of demonstrate there's something called, you always need to do authentication before you do authorization. You should always force that kind of thing to happen. So we come up with a scenario to demonstrate that particular use case. And then the third category, we're really looking at all the interesting research projects. Not all the research projects can be done in this fashion, like the wonderful talk you gave about the about a smartphone imaging retrieval and visualization. I think it will be difficult to put out there, but there are a lot of tools can be done using this kind of fashion. We're able to working with some of the IEEE security S&P authors. We communicate with them. We're able to make a few of them possible. And this is fairly interesting, and I believe should be something we want to really push forward. Because if you have some state-of-the-art research project, you want people to see what is going on. You don't want people to spend hours and days and even weeks to reproduce your results. And I can tell you, just reproduce this work, take the entire team 2 weeks just to reduce one, simply because there are too many issues with the Linux version we picked. We tried so many different versions of Linux, tried so many versions of the compilers. We just simply cannot get exact results the authors got. So just if we can get everything done, we can clear up all the dependencies, make sure it's available on the web interface, and everybody can take a look. And then going from there, I think everybody's life, it will be easier. And the fourth category are 3 use cases of developing cryptography work. And we know cryptography is extremely, extremely important, and every tiny implementation is important. So we have one as a padding oracle attack, and it's really leveraging how your browsers or how I think it's CBC block cipher, how they react to the padding. So they will give you an error indicating your padding is not right. So attacker can leverage in that kind of knowledge and be able to figure out what might be the cases of your encrypted code. So 3 outstanding, really well-designed cryptography projects. Is actually some of the projects is being done by University of Maryland. They're teaching the cryptography class. Those are the 3 course projects contributed by Jonathan Katz from University of Maryland. So those are the things we have right now. Of course, we can build up this whatever available pieces, and those are the things we have. And I have a very short video. Oops, you know what? I have a very short video. I think it might be 1 minute. Just briefly talking about how I can do the voice over that. So this is the earlier stage when we made 7 of those containers, and what happened here is you just pick one of those, and then going from here, you're going to read the description. What is the project about? What is how are you going to do this? So it will link to whatever the project you have, and then you can click on try it. And we used to do Google Gotcha service, just making sure that we don't get the denied service attack on our own web server. So going from there, you basically pick on some of the images, go from there. And you can hit the launch, and then you basically have a few of the system going to be available. So if you click on launch. So in this particular case, we present 2 different things. So you're going to using one tab for server, one tab for client, and another tab is just for instructions. So even though we made it so that you can do it on iPad, it will be so much easier to do it, using multiple monitors on a desktop or laptop. So those are instructions. Most of the instructions are pretty straightforward. It tells you what to do. So you should be able to follow the instructions, be able to achieve most of it. And then towards the end is where we throw out some really challenging questions. We ask you to think about certain things. That's a typical design of the system. And and we also encourage the users to take the survey. It turns out the users are not very enthusiastic about taking out a survey. So so far we probably only have five users give us a survey, fill out a survey. But the survey responses were pretty positive. And just from the over about one half in the a little bit about 45 days, and those are the users that we have. And as you know, the number is not great simply because not many people are aware we have this project going, and we spend more time developing the program rather than making sure that everybody knows about this project. So we're going to certainly do a lot more promoting of the program, but right now, just looking at the map, we realized one thing. We probably should have make the project available in multiple languages rather than just in English, because initially we have a lot of people from China, from other countries, starting out using this, and then day 2 or day 3, just nobody coming simply because they couldn't follow the instruction exactly the same. But anyway, those are the basic data here. And break down to different use cases. Our current perception appears to be anything that addressing the basics attract a lot more users. For example, ARP spoofing, SSL scraping attract a lot of people, and SSH honeypot, and I think there should be ones really high profile. A Heartbleed also attract a lot of users. So anything that people take a look and say, oh, this is interesting, I want to take a look at it, appears to be very attractive to the different users. But as you can see, we spend a lot of effort trying to make something really interesting available to everyone. But users, we don't have enough user space to tell us how they feel about it, whether it's really making sense or not. So the good thing is we are going to make more people to know about this project. IEEE is officially going to roll out this project, a news announcement pretty soon. And the thing we learned from the numbers is it turns out word of mouth really make a huge difference. If you just simply sending an email and say to an organization, say, hey, we have this thing going on, chances are you're not going to track a lot of users, okay? You probably really want to talk to your colleague, you tell them, hey, you know what? I tried this, it's really interesting. Maybe you can give it a try as well. So that turns out to be a very successful recruiting. So we rely on you to pass this information and talk to some people that you know about. And we certainly need to build a much stronger and much broader collaborative network, making sure that if you have something wonderful, if you have some tools or some of the research going on, you want to share this with everybody, just please contact us. And we need to translate that one into multiple languages. And in addition to this, I just want to make it clear there one way you can make this contribution pretty easily, because currently we have 2 types of containers. One of the Docker containers is where it's hooked up to the web interface. Those are the 12 containers I talk about. But you can actually just using whatever your containers, Docker containers, and we can add a link on this IEEE Try-CybSI website. So there will be a portal, there will be a link to the container you just make. We don't have to make it, using the web interface. People can simply download your containers, be able to save your work, and go from there. And we do have some of the instructions for doing this. And I just quickly go through the process. If you're interested in making this happen, making sure your applications are Linux and Unix compatible, because right now Windows is not supporting it. But the good news is, if you're thinking about it, Windows is already pushing out a bash shell, so likely Windows is going to be able to support Docker as well. So making sure it's supported, and you can develop your Docker file. You pick some of the base images, go from there, you install all dependencies in your applications. And we recommend 2 different kind of base image. One is using something called WATI, that's for any of the command line use base. The other one is the VNC-based image. So we already created 2 base images. Depends on whether you have a graphic user interface or not, don't have a graphic user interface. And go from there, you can just create your app. It should be a pretty easy process. Once it's being done, you just simply build image and the push image to the Docker Hub. And go from there, we can pull your image and get it on the IEEE website. And as you can see here, those are the Docker file looks like. It's actually pretty easy, pretty straightforward. You just tell the Docker containers, the base image, what are things you need to install, what version of the things you need to put in there. And your Docker images is going to show you all the images you have with all the different kind of versions. And you log into your Docker, and then you can push the images, and you can specify what kind of version you want. So you can try many different things. And this is really a great tool to promote your own research work or educational work. So what's going to happen next is we're kind of still debating where this thing should be going. But we certainly want more containers. We certainly want more users to try out a project. But as in the discussion, we're going to do this host of security challenges. And using this Try-CybSI website, well, in the long run, I think it is possible we can build this digital hands-on library simply because all the tools are there, dependencies no longer issue. And we do see a great value of doing this. And by the way, if you read the news lately, Pentagon is kind of working in a certain way with the hackers. They are going to reward hackers if they are able to taking down some of the non-crucial websites for Pentagon. I think they get called Hack the Pentagon project. So there's something, along the line, we want to give the educator, researchers, and users an opportunity to work on some of the really challenging security questions. And I really want to thank Professor Dr. Greg Shannon, and his vision to come up with something like this. And Professor Rob Cunningham and Wolf from SRI, they are currently the IEEE Cybersecurity Initiative Chair and the Vice Chair. And also Dr. Jonathan Katz from Maryland, Anthony Jones from Berkeley, and Mr. Brian Kirk from IEEE. They're kind of providing a lot of support for this project. Here at Purdue, I want to thank Professors Spafford and Joe for running this great program, making sure that we have very good visibility, be able to attract this IEEE project here at Purdue. And I want to thank Dr. Chu for his initial input into the program. I want to thank Dr. Melissa Dark for her inspiration on cybersecurity education, and Dr. Rogers for his support to make this project even possible. And of course, those are the people actually, get the website developed, get everything accomplished. So Dr. Karasum, Mr. Rajesh, and Ms. Lan, and the Fahim team, and Kalu. So those are the folks that make those 12 cases possible, present there. So with that, that's the thing I want to acknowledge now. And in the future, this is the part I want to acknowledge is you. Okay, I want you to voice out this project. I want you to play around with this project. Tell us what do you think about this project. So
great, Justin. Thank you very much.
Thank you. Okay, thank you.